In this video, we will see the design of Turing machine for for addition of two numbers. Addition of two numbers. Okay, addition of two unary notation using unary notation. Let us see what is unary notation. So if I am let us say the two numbers are a is equal to 4 and b is equal to 3. It can be any number. You can use the same Turing machine for any numbers. Okay. So a is represented using four ones or four zeros. B can be represented using three ones or three zeros. So this is your unary notation. You use the single digit 0 or 1 to represent the given number. Okay, if it is 3, use three zeros or three ones. If it is 8, use three ones or, eight ones or eight zeros. Okay, so that is the unary representation. Let us see how we can do a Turing machine for this. So your input tape, it will have blank space before the string, after the string also. So four ones, four zeros, sorry. I am representing using zeros. Okay, four zeros. In between, I'm using a separator to separate two numbers. Next number is 3. 4 plus 3. After this, it's a blank space. So this is the 4 representation. This is 3 representation. In between, you have a separator to separate these two numbers. Now let's see how you can add these two numbers. So you have to, it's just addition, no? So addition is you keep everything in mind, keep on adding, right? So you just keep reading all these zeros and okay, and find out what is the count at the end. So let's see how we can draw state transition. Q naught, you keep reading all the zeros, don't do anything, keep moving right until you find a blank space. In between, you have a blank space, no? Until you find a blank space, change that blank space to 0 and keep moving right. Because you have to have all zeros in the input tape. In the input tape, you will have to have the zeros, right? That then only you can add the total number of zeros. So you change that blank space to 0 and keep moving right. In the Q1 state also, you will keep reading the zeros until you find another blank space. Okay, don't do anything to the blank space, move one step left. Okay, so what is 4 plus 3? It is 7, right? How many zeros you have here? 1, 2, 3, 4, 5, 6, 7, 8 zeros you have. So you have 1 zero extra. So you move one step left, change the 0 to blank space and accept the string. Q2, okay, change the 0 to blank and move one step left and accept the string. So this is the logic for all additions. If you change this number also, see if I have 5 plus 2, that is, sorry, 5 plus 3, that is 8. How many zeros you will have? See, 1, 2, 3, 4, 5 zeros you will have. You will have separator in between and another 3 zeros. After this blank space, before this blank space. So you will read all the zeros until this blank space. You will replace this blank space by 0. Okay. How many zeros you will have in total now? 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros you have. So you read till this blank space, move one step left, change the 0 to blank and accept the string. So this logic is same for addition of all the numbers. Okay. So you change the middle blank space to 0, move till blank space, move one step left, change the 1 0 to blank space and accept the string. So this is addition of two numbers. Let us see how you can draw a Turing machine for, design a Turing machine for subtraction of two numbers. Subtraction of two numbers using unary notation. Okay. So in this there are two conditions. Okay. What if M and N are two numbers. Say M is equal to 5, N is equal to 3, or M is equal to 4, N is equal to 2. M and N are two numbers. So the M minus N if M is greater than N. Okay, 0 if M is less than or equal to N. If M is greater than N, so here in the 422, 4 is greater than 2. Then you perform the subtraction, 4 minus 2. Okay, so if it is 2, M is equal to 2 and N is equal to 4, then that is M less than N. Then you just, your Turing machine should give the result 0 for that. Okay, so these are the two conditions that are followed in subtraction of two numbers. Now let's take an example. M is equal to 4, N is equal to 2. So I am representing 4 with 4 ones, 2 with 2 ones. Okay, the Turing, I'm sorry, the input tape would look like 1, 2, 3, 4. Okay, I'm using a 0 here to separate. The previous example we used, I mean, for addition, we used blank space as separator. Here we are using 0 as separator. Then you have 2 ones, then blank spaces. Okay, so previously we were just adding the numbers. That's why we were reading and counting how many ones are there in the tape. But here we are subtracting the numbers. So we have to, remove the number so that we can match this one with the one after the separator. So we have to replace this with blank. The previous example, we did not replace. We just kept on reading because we have to add all the number of zeros. But you are subtracting. So we have to replace the ones. So you replace first one with blank, keep moving until you find another blank, move left, replace that with blank. Okay, come back, replace it with blank, go and replace it with blank. You could replace this 0 with 1, and in the end, just count how many digits are there in your whole this input tape. Okay, now let us see how to draw a state transition line. Q1, so your input tape is 1, 1, 3 ones. I'm doing 3 minus 2 or 4 minus 2. Okay, sorry, wait. We are doing 4 minus 2, right? So 4 ones. Here you have a blank space. Then you separate. There are 2 ones after this and blank space after this. Okay. So first Q1, you change one, you replace one with a blank space and keep moving right. In between, you will have any number of zeros. Don't do anything to the zeros. Keep moving right. Only one zero you will have. Sorry. And you will have any number of ones. Don't do anything to those ones. Keep moving right. Okay. Until you find a blank space. This blank space. Blank space. Don't do anything to the blank space. Move one step left. And then Q3. Okay. Q3. You have replaced this with blank. Okay. And moving one step left. You replace 1 with 1, keep moving left. 0 with 0, keep moving left. Okay, you do perform this until you find a blank space. Okay, keep moving. You replace this with blank space, replace this with a blank space. Okay, and keep moving left. Okay, and then you replace this with blank, replace this with blank. Okay, everything is now replaced. Everything is now replaced, and then you have 1 0 here. So in the input tape, now you have only one 1. Okay, but the result should be 4 minus 2. Right. So it should be 4 minus 2. The output should be 2. So first you have replaced this one, then you have replaced this. Moving back until you have a blank space, move one step left, right. Replace this with a blank. You keep moving right. Replace this with a blank. You keep moving left. Okay, replace this with a blank and you keep moving right. You replace this with, sorry, you find a blank space, moving one step left. And you should have found 1, but you have found 0. So what would you do when it is 0? You don't have to do anything. Okay. So sorry, you have to replace this 0 with 1. So where this state would come in between Q3 and Q1. So you have to draw a state here. Okay. You have to draw another state here. If it, these are all the transition we had already. Q2. So if it is 0, you change it to 1 and move one step left. One step left. Okay. Then you will have 1. You replace that with blank. So now this is how you perform the subtraction. Sorry, you don't replace this with blank. You just accept from there. If you replace it with blank, you will not get output 2, right? So you don't replace this. I will explain it again. This is your input tape. 1, 2, 3, 4 ones. Then you have the separator, 2 ones, and then blank space. Okay, now your input head is here. You replace this with blank space and you keep moving towards the right until you find another blank space. In between, you will have any only 1, 0, put that in the self loop. Any number of ones, put them in the self loop until you find a blank space. Move one step left. You will have a 1. Replace that with a blank. Okay. Now you keep moving left until you find a blank space again. Okay, you keep moving left. You keep moving left. In between, you will have any number of ones or 1, 0. Put them in self loop. You keep moving left until you find another blank space. Then again, you will have another 1. You replace that with a blank. So this will keep going on. Okay, you will have replaced this one, keep moving, and then you replace this with blank, keep moving this side, you replace this with blank, keep moving this side. Okay, until you have a blank, move one step left. You should have found 1, but you have 0 here. So what should you do if you have a 0? Then that means you have reached the separator. Okay, so if it is 0, you change that 0 to 1, move one step left and accept the string. So now if you take the input tape, you have 2 zeros. So that is 4 minus 2 equal to 2. That is your output. Okay, so this is how design a Turing machine for subtraction. It works for any numbers. 5 plus 8, 5 plus, sorry, 3, 5 plus 5 minus, sorry, minus 1. Okay, 10 minus 8. For any number, you can use the same Turing machine. Now we have uh, we have seen how to design Turing machine for m minus n if m is greater than n. Now let us see what if m is less than or equal to n. So the example is m is equal to 2, n is equal to 4. Here m is less than n. Result should be what? 0. Okay, so the Turing machine is same. This is the same Turing machine, okay, base, and you just have to add one more, just add one more state. Okay, Q naught. So everything is same. One is one, okay, R, blank space to blank space L, Q3. Okay. So there's no foundation. Q3, 1 to 1, blank space left. Okay, if there are, sorry, and then if you have 0 here, you change that to 1. Okay, Q4 and accept. Okay, Q3, 1 to 1, comma L, 0 to 0, comma L. You repeat the process. Blank space to blank space, comma L. So all these we saw already in this Turing machine. Okay, this will uh, so here, this was the accept state for the previous Turing machine, right? But this shouldn't be the accept state for this one because accept state should the string should be accepted when it is zero. So this will not be accept state. Okay. So when your next input take is 1 1 0 1 1 1 1 blank space. Okay. So you will have one first this you will replace with blank. Move towards right until you get this blank. One step left, then replace with blank. Again move left. Okay, replace this with blank. Move right. One step left. Replace this with blank. Come back. You should have the next digit as 1, but you have 0. If it is 1, you will take this path. But this is 0, right? So what if it is 0? Then you will take another path, 0. Replace that 0 with blank. Okay, Q5. Put everything in the self loop in between. Okay, and until you find another blank and accept this string. Okay, so this is how you design a Turing machine for subtraction of two numbers when n is less than or equal to n. Thank you.